Hi all, welcome to Think Maths. We are dealing with NCERT Class 10 Maths, Chapter 1, Real Numbers. So in this session, we are going to discuss about Fundamental Theorem of Arithmetic, Introduction, and we are going to discuss about Example 5. So let us get into the video. So what is Fundamental Theorem of Arithmetic? It says that every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So before discussing about this theorem, let us discuss about composite number, prime number, factors and uniqueness. So what is composite number? So let us take a number 16. So 16 can be expressed as 2 into 2 into 2 into 2 into 1. So a composite number is nothing but divisible by 1 and itself. That is 1 into 16 and some other numbers also. So it is divisible by 8. This 16 is divisible by 8, 4 and some other numbers. So a composite number is nothing but divisible by 1 itself and some other numbers. So such numbers are called composite numbers. So let us take prime number. So prime number is nothing but divisible by 1 and itself. So prime number is greater than 1 and divisible by 1 and itself. Suppose I take a number 7. So 7 is divisible by 1 and 7. No other number is divisible by 7. Such numbers are called prime numbers. So what are factors? Suppose if I take the number 15. So 15 can be expressed as 3 into 5. So these 3 and 5 are called factors. Okay. So next is uniqueness. So here I take the number 140. So here the number ends with 0. So this number is always divisible by 5. So let us take the prime number 5. So I start with 5. Okay, 5 into, so 140. If I divide by 5, so 2 5s are 10, remaining will be 4, 28. So this 28 is divisible by 7. So 7 4s are 28. 4 is divisible by 2. So I can stop here. So 140 can be expressed as 5 into 7 into 2 into 2. Also, if I start with 2, so 140 is also divisible by 2. Okay. So I start 140 by dividing by 2. So if I divide by 2, 7 2s are 14, 0. Again it is divisible by 2. So 3 2s are 6, balance 1, 5 2s are 10. So 35. So 35 is divisible by 5, 7s are 35. So again 140 can be expressed as 2 into 2 into 5 into 7. Suppose if I start with 7, 140 is divisible by 7. So 7 2s are 14 and this 0, okay, 20. So I can take 5, 5 4s are 20, 4 is divisible by 2, 2 2s are 4. So this can also be expressed as 7 into 5 into 2 into 2. So here in all the three cases, the factors are same, but only the order is different. Okay. So what is fundamental theorem? So every composite number. So this 140 is a composite number because 140 is divisible by 1 and 140 and some other numbers. Okay. So 140 is a composite number. So every composite number can be factorized. So we have factorized here as a product of primes. So these 5, 7, 2 are all prime numbers. It's a product of prime and this factorization is unique. So no other prime occurs in any order. So in all the three cases, there is 2 2s, 1 5 and 7. So only order is different. Okay. So expressed as a product of primes and this factorization is unique. Okay. Apart from the order in which the prime factors occur. So order may be different, but the factorization will always be unique. There will not be any 2 3s in other cases. If there is 2 2s, in all the cases, it is 2 2s. Okay. So this is fundamental theorem of arithmetic. Okay. So next is example 5. So consider the number 4 power n, where n is a natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. Okay. So they have given the number 4 power n. So here n is the natural number. That is 1, 2, 3, 4, 5 counting numbers. We have to check for any value of n, 4 power n ends with the digit 0. Suppose 4 power n ends with the digit 0. Okay. That is for any value of n, if we put any values, suppose we get the answer as 40. So 40 means if we factorize this, we get as 2 into 20. Again, if we factorize this, 2 into 4 5s are 20. So 4 5s are 20. Again, if we factorize 2 into 2 into 2 into 5. So if I factorize this, I get the factors 2 and 5. So there should be factors 2 or 5 in this. So 4s can be written as 2 to the power 2. 2 square is 4. So 2 to the power 2 power n. So this is nothing but 2 power 2n. Okay. So 2 power 2n. This means for any value of n, if we substitute n is equal to 1, it will be 2 to the power 2. So if we substitute n is equal to 2, and this will be 2 to the power 4. So whatever be the value of n, the values will be in 2 into product of 2's. No other prime will occur here. Okay, for any value of n, this value will be 2 into 2 into 2 into 2 something. But there will be no other primes. But we need a prime 5 because if it has to end with 0, it will be divisible by 5. But we don't get the prime 5 here. I think you got the point. Okay. So we can say that there is no value of n for which 4 power n ends with the digit 0. Okay. Okay, children, can you understand? So let us write the problem. So they have given if 4 power n has to end with 0, then it would be divisible by 5. Okay. So if it has to end with 0, it would always be divisible by 5. Okay. Therefore, prime factorization of 4 power n would contain the prime 5. So we took 40. Okay. So 40 can be expressed as 2 power 3 into 5. Okay. In prime factors, we can express this as 2 power 3 into 5. So we found 2. But there is no prime factor 5. Because 4 power n is nothing but 2 square to the power n. 4 is nothing but 2 square. So we can write as 2 to the power 2n. So here n is a natural number starting from 1, 2, 3, 4, 5. So if we put any value of n, this 4 power n will always be in 2 into product of 2's. Only 2's. No other prime will occur here. But we need 5 to conclude that 4 power n has to end with 0. But there is no factor 5 because the only prime factorization of 4 power n is 2. So by fundamental theorem of arithmetic, there are no other primes in the factorization of 4 power n because fundamental theorem says that factorization is unique. So this is unique in which order they appear. There is no other factor 5. So there is no natural number n for which 4 power n ends with the digit 0. I think you can understand this problem. If you have any doubts, you can comment me. Thank you. That's all for this session. We can meet in the next video. If you like this video, please subscribe and like. Thank you. Thank you.